Okay, so this lesson is on addition and subtraction of rational expressions. And I'm going to kind of go back to, I don't know, 4th grade when you learned how to add fractions and talk about the concept of a common denominator, because then we're going to apply it to these big, ugly fractions. So if I gave you 1/2 plus 1/6, you could say that your common denominator is a 12. And then you would multiply this guy by 6/6, because that's like multiplying by 1. And you'd multiply this guy by 2/2. And so that would give you 6/12 plus 2/12. And then you would add them together and give you 8/12. Notice you do not add the denominators. And then you would have to reduce that by 2, well, actually by 4, to get 2/3. Okay, so if I look at the same problem again and say, okay, I have 1/2 plus 1/6, and say, well, I know that I don't have to go all the way up to a 12. I know that I can go to a 6 because a 6 has a 2 in it. So if my common denominator is 6, then I am just going to give this guy a 3/3. And the way that I want you to think about it, and I know this is very basic, but it's going to help you with these ugly ones, is that this is 2 times 3. So see, they already share the 2, and he has a 3 that he doesn't. So that's why we have to give him the 3. So then that makes that 3/6 plus 1/6, which is 4/6, which reduces to 2/3. So either way, you get the same answer. But if you look at the problems that are on this screen, they get big and ugly. So we don't want to go with the 12 if we can go with a 6. So you're looking for a common denominator, but you're looking for the smallest common denominator. All right, so now when I look at these, the first thing I'm going to be looking at, is there a denominator? And I'm going to be looking to factor them to see if they have any factors in common, like the 2 and the 6 had a 2 in common. So for number 1, I have an x minus 6 and a 2x plus 1. And I cannot factor either one of those. They have nothing in common. So I am going to have to give them each the other one. So he's going to need an x minus 6 over an x minus 6. And he needs the 2x plus 1 over a 2x plus 1. My denominator, and this is just me being lazy, I'm just going to go ahead and write it once. So that is going to be my denominator. The top, I'm going to multiply these two together. So that's 6x squared. Let's see, minus 2x and plus a 3x. So plus x minus 1 plus, and then distribute that to 2x minus 12. And then I'm going to combine my like terms. So 6x squared plus 3x minus 13 over 2x plus 1, x minus 6. And you have to make sure that the top doesn't factor and that you can't cancel anything. Just like when we got the 8/12, we could reduce it. So when you get to this step right here, you want to make sure that you can't reduce it. A lot of times you can't reduce it, but you know, the one time that you get slack and sort of assume that nothing is going to factor and cancel, that will be the one problem that does factor and cancel. So stay on your toes, be smart mathematicians. Okay, number 2, on the bottom I have an a minus 3 and an a minus 5. I can't look at this as they both have an a. Those are of 2 different binomials. So I'm going to have to give him an a minus 3 and give him an a minus 5. And I'm going to start getting lazy and not write this, even though I know that's what I'm doing, because that's the only way that keeps it legal, because I'm multiplying by 1. But I'm going to kind of stop writing it a minus 3 over a minus 3, and I'm just going to write the a minus 3. My denominator is now that. I'm going to multiply the top, plus 4 minus 5 minus 20 plus a squared minus 12a plus 27. I miss doing this in front of a live class because y'all catch all my mistakes. So we're just going to hope for the best. Minus 13a plus 7 over a minus 3, a minus 5. Now I can check to see if the top factors, but again, at this level, we're smart mathematicians. If it's going to factor, the whole point of it factoring is so that it cancels with something on the bottom. Well, on the bottom, I have two parentheses that end in a 3 and a 5. Even if this sucker up here does factor, that's a 7. Like, there are no factors of 7, so that I'm going to put into parentheses and end with a 3 or a 5. So even if this top does factor, it's not going to cancel with the bottom. So I don't have to. There's my answer. So again, be smart. Okay, so now we get into the fun part. So in looking at number 3, I can factor the bottom. Oh, I don't want. Oh, that's right. I can factor the bottom. I can GCF a 3. So now I can see that the bottoms have an x plus 2 in common. Well, there's no need to give everybody an x plus 2. They both have it. The only thing that this one has that the other one doesn't is a 3. So all I have to do is come over here and give him a 3. Now, again, remember, technically I'm giving him a 3 over 3. But again, I'm just going to write it once because I'm being lazy. So my denominator is the 3 and the x plus 2 because that's what I'm bringing both denominators up to. The top is chilling and the bottom is going to get a 3. Now, here's what you have to watch out for. That negative, that's a shark, and that has to get distributed. So I'm going to distribute the 3 and the negative at the same time. So negative 3x plus 9. And then I'm going to clean, and nothing factors and cancels. All right, let's go look at number 4, and I hope you can kind of see now that this bottom factors. That should be the first thing that you're trying. I can see that they both have an x minus 11, so he's going to get a 3. My denominator, this numerator stays the same because he didn't get anything. And then minus 48, and then I'm going to clean. Let's see, minus 39. And then to check my factoring, he's got a 3. Well, there's no taking a 3 out of the top, and that's an x plus 11, and this guy's not going to factor with anything with an 11 in the back of it. So I know he's done. Number 15, these are squares. So they have an x minus 7 in common, so he needs an x plus 7. My denominator will then be x plus 7, x minus 7, because that's what they both have. That's a 16 minus. All right, I'm taking the negative with the x. So minus x squared minus 7x. And that's a really big part people are going to stumble on right there. They're going to have a positive 7x. And at this stage in the game, we're not looking for sort of kind of right. We're looking for exactly right. So you really, really, really want to draw your attention to those sharks hiding in between the two fractions. And at this level, that's kind of what we're testing on, is to make sure that you're getting those nitpicky kind of details. So stay focused. So I'm going to have negative x squared minus 7x plus 16, just to rewrite it in order. I could GCF a negative out of the top, but after I do that, the 16 is not going to factor anywhere with a 7 and 7, so there's no point. Number 6 is really similar to that, and so is number 7. And I'm looking for something that maybe is a little different. Let's look at number 9. Okay, so number 9 starts very similar. So he needs an x minus 4. So that's my denominator, and then that's a 16. There's no shark. So 2x minus 8. So I have 2x plus 8 over x plus 4, x minus 4. And this is where if you lower your guard, this is where the canceling right here at the end is going to bite you in the butt. So you guys can see, especially now that I'm pointing it out, that you can GCF a 2 out of the top. And then he can cancel, and it leaves you with, which is very different than that one. So just, again, stay on your guard and be careful. Let's see. 10. Yeah, 10's a good one. And then we'll skip 11. Okay, so let's do 10. So 10, I'm going to GCF a 2. And I'm going to factor the bottom. Okay, so it's sort of like breaking it down for parts. So I can see that they have an x minus 6 in common. He needs a 2. And he needs the x plus 2. So then my common denominator is a 2, an x minus 6, and an x plus 2. That way everybody has all three parts. So the top is going to be 5x plus 10 minus 40, which is 5x minus 30. And I hope you can already see it, that the 5 and then the x minus 6's can cancel. There you go. Okay, so now I want to take a look at these guys. So these are what I love to call wedding cakes, but they are extremely wobbly wedding cakes. You want layers that go all the way across before you go to Bojangles and same change flip it. So I'm going to put the 4/1 and the 5/1, and I'm going to get a common denominator for the top 2 layers and then a separate one for the bottom 2 layers. I'm going to sure it up a little bit, and then I'm going to go to Bojangles. So the top common denominator is going to be a 3, so he needs a 3. So that's going to give me x minus 12 over 3. The bottom common denominator is an x. And so that's going to give me 5x plus 1 over x. Okay, so now I have a wedding cake where my layers go all the way across. So now I'm going to same change flip him, which is amazing how many times we do this in calculus. So I need it to be, you need it to be second nature. I don't have anything that cancels, so I'm just going to put all the parts together. Yes, you could distribute if you wanted to, but it serves no purpose. So, you know, have at it if you want it. But again, it doesn't do anything. Okay, so just so you can see another one of those, number 13, I'm going to put these guys over 1. Top common denominator is an x, so that's going to give me 4 plus 2x over x. He needs a 2x, so that's going to be 1 minus 16x over 2x. Flip it, nothing factors. However, I can, oh wait, I said nothing factors. He factors, although I don't think it does anything. But that x and that x, because they're single, can cancel. Now this 2 and this 2 cannot, because they're both on top. So I have, it depends if you want to leave it like this and multiply it with the 2, you'll have a 4 and a 2 plus x. If you want to leave it like this and multiply it by the 2, then you'll have a 2 and a 4 plus 2x. I don't care. It's the same thing. Over a 1 minus 16x. Here you could distribute the 4 and get 8 plus x, 8 plus 4x, sorry. And you could do the same thing here, 8 plus 4x. So, you know, this or this or this, they're all the same tops. For this one, common denominator on the top is going to be an x squared, so he needs an x. And the bottom is going to need a 5x. So 3 plus x over x squared over 10x minus 4 over 5x Bojangles, I can take a 2 out. I don't think it's gonna do me any good. That X and that X squared can go, but I think that's it. So I have a 5 and a 3 plus X. And on the bottom, I have a 2 and an X that are single, and a 5X minus 2. So I hope this was a really good reminder of common denominators, some wedding cakes, and a little Bojangles. Feel free to go back and watch it again, and let me know if you have